little bit patience and then just apply the limit. So first part, NP lemma, which is about testing f is equal to f0 against f is equal to f1. Right? This is what this is. And level is alpha. I talk about non-trivial levels. That means alpha is strictly greater than 0 and less than 1. Alpha is equal to 0 and alpha 1 is equal to 1 are trivial cases, which are not of practical importance. So let us not talk about that, right? Because alpha is equal to 0, you can get by the test phi x equal to 0 all the time. Right? Phi x equal to 0, so probability of type 1 error is 0. And what would be the power of this test? Power would also be 0, right? Alpha is 0, that means you don't want any type 1 error. But that would come at the cost of type 2 error. So type 2 error for that could be 1, because phi x equal to 0 test, right? That is a UMP alpha test you can. Anyway, so let us consider this thing. So the first part, it says existence. It says UMP alpha test of the following form. UMP alpha test exists. So there exists a UMP alpha test. There exists UMP alpha test having form phi x is equal to 1 if f1x is greater than c times f0x, gamma if f1x is same as c times f0x, and 0 if f1x is less than c times f0x. Right? Where c and gamma are such that E or under f0 of phi x is equal to 1. Is that okay? So you see, this talks about there will always be a one UMP alpha test which will have this form for some gamma and c, so that holds, right? So what it suggests? It says if your job is only to find UMP alpha test, look at the test of this form such that gamma and c are satisfying that, right? That would be UMP alpha test. Any test of this form such that gamma and c satisfied f0 phi x are equal to alpha would be UMP alpha test. But the question many times, question will arise, can we talk about more UMP alpha test? And that is second thing is about the uniqueness. It says if there is any other UMP alpha test, it would be of the same form. At the most, it can differ in this region, where f1x is same as c times f0x. Is that okay? Now note that for this UMP alpha test, which talks about existence, it takes you probability of type 1 error to the maximum alpha. This was not a requirement. You required this to be less than or equal to alpha. Any test for which this is less than or equal to alpha. So it gives you one test for which this is exactly equal to alpha, and it is UMP alpha test. Your requirement should be less than or equal to alpha, right? So this is, so if you have to find another UMP alpha test, another UMP alpha test may be there for which expected value of phi x is less than or equal to alpha, and power is same as the power of this test. Of course, no other test can have a power more than this because it is a uniformly most powerful. Is this clear? One is only about finding the UMP alpha test, which you can get using this. If you have to find more and more UMP alpha test, try to use the part 2. Try to prove, because any UMP alpha test would be of that type. Among all of them, you see which one of has a power same as this. And that would also be UMP alpha test. Is that okay?
Probability of type 1 error should be equal to alpha, but we require that it should be less than equals to alpha.
Yeah, so L is equal to alpha is also fine.
Why should not we directly use the second part?
No, second part only says that UMP alpha test will always be of this type. any test of that type may not be a UMP alpha test. Is that okay? It says any UMP alpha test would be of that type. So that means you look at all the tests which are of that type. Among them, find the one which has a power same as this one. There will be so many tests of that type which matches with this. Over here, there will be so many tests. But among them, only those would be uniformly most powerful tests for which power is same as this. So power comparison makes sense. Otherwise, the second part only says that UMP alpha test would be of this type. Any test of that type may not be UMP alpha test. Is that okay? I hope I have been able to clarify a bit, right? So now that is why I'm saying that those problems are very interesting, those uniform 0 theta, exponential 0 theta, and so on. First, you find the UMP alpha test and look at what are the all possible kind of tests which have that property, and then you are done. You want me to explain that in more detail so that you can understand how to apply the UMP alpha test for all kind of situations. So let me just clarify today that, and then tomorrow I can take, so that this UMP alpha test is clear to you. Let me go very slowly. Let us consider uniform 0. You wanted to consider that exponential theta, right? So uniform 0 theta, I think I have already considered. Which one do you want me to consider? Exponential, uniform 0 theta, exponential theta? Yeah? Uniform 0, which one? You see, both are same, it doesn't matter. Exponential, okay. So x1, x2, xn, IID. Exponential theta, and let us say, put me here sigma naught, right? H naught is theta is equal to theta naught. Theta is bigger than theta. Sorry, theta is equal to theta 1. So I'll keep provoking you to answer things. So I would expect that you would at least respond, right? Because that would give me a feedback that you're understanding or not understanding. Right? I can take, because theta naught and theta 1 are known quantities to you. So one of them would be bigger, one of them would be smaller. So let us assume, consider the case theta 1 greater than theta naught. Theta 1 less than theta naught you can consider. Similarly, let us look at f theta x is how much? It is exponential theta sigma naught, so it is 1 by sigma naught to power n e to power minus summation xi by sigma naught e to power n theta by sigma naught. Is that okay? And what is the range? Only when minimum is bigger than theta. Note that first of all, you should only bother about ranges of x which are of interest. For me, only distributions of interest are theta naught and theta 1, right? Only, so theta naught is over here and I have taken theta 1 bigger than theta naught. And I know that under exponential, minimum is always bigger than theta. So I have to, my range of sample is only minimum is bigger than theta. So what values of theta should be of interest to me? Because my distribution is either under theta naught or under theta 1. It should be greater than theta naught, right? Otherwise, I need not bother, right? So I should consider only x1 greater than. So I know that x1 is greater than theta naught with probability 1, right? And for me, anything which is of probability 0 doesn't matter because it's a course on statistics. So anything which is of 0 probability doesn't matter. So I would consider that my x1 is always bigger than or equal to theta naught, right? Because your distribution is either theta naught or theta 1. There is nothing else. Okay, so what it says is, let us consider delta x, which is f theta 1x. So I'm trying to look at a test of this type. Yeah? Gamma says that. So look, let us look at what are the possible tests of this type. K times f theta naught x. You can put it C. What is that quantity? 1 by sigma naught to power n e to power, because this does not depend on theta, so they will come outside. E to power n theta 1 by sigma naught minus k times e to power n theta naught by sigma. Is that okay? You see, everything depends on the sign of delta x, right? Which is f1x minus c times f theta, sorry, c times. Right? So I'm trying to look at what are the possible tests of those type, and among them I choose the one which satisfies EF at naught is fx equal to alpha. Is that okay? So what are the possible scenarios? Note that this is a fixed quantity. So one possibility is, yeah, that C is, that means this is always less than 0. This is less than 0 means C is always bigger than e to power n theta 1 minus theta naught by sigma naught, because C would be a known quantity. Case first, there is some problem, right? No, this is only for x1 bigger than theta naught, right? Actually, no, I made a mistake, right? Because ranges are different over here and here, right? Because this is this only when x1 is bigger than theta 1. So let me write it down, doesn't matter. So my x1 I know is always bigger than or equal to theta naught. So the first case would arise when x1 is between theta naught to theta 1. Because my board depends on where my x1 is. If x1 is between theta naught to theta 1, f theta naught is 1. Sorry, this would be some quantity. This will contribute, and this will not contribute. Is that okay? So that becomes minus c times sigma naught to power n e to power minus summation xi by sigma naught e to power n theta naught by sigma naught. Is that okay? Second situation is when x1 is equal to theta naught, I need not bother because that probability would be 0. x1 is bigger than theta 1. x1 is bigger than theta 1, what happens? Then both are contributing. Then both are contributing. What does that mean? That means it E1 by sigma naught to power n e to power minus summation xi by sigma naught, then e to power n theta 1 by sigma naught minus c times e to power n theta naught by sigma naught. Is that okay? I hope it is visible to you. Is that okay? So these are the possible things. I know that there is a UMP alpha test of this type. The only thing is I have to find now C and gamma. Of course, would depend on sign of this. I have to find C and gamma such that that is exactly equal to alpha. So let's look at what are the possible cases of C's, which will give me different tests. One is I take C to be less than alpha, C to be less than 0, right? Because sign, because everything here, the test, everything depends on the sign of f1x minus c times f naught x. So one thing is I take, if C less than 0, it is positive throughout, right? C less than 0, then delta x is always positive, right, for every x. And if delta x is positive, then what is my phi x? Phi x is always 1. There is no scope for anything else. But if phi x is a 1, what is e theta naught phi x? Phi x is 1 for every x. This is 1. I wanted this to be alpha. So there is no C and gamma which can satisfy this if alpha is between 0 to 1. Alpha, because I have taken alpha to be strictly between 0 to 1. So there is no C and gamma which satisfies this. So that certainly this doesn't fulfill my goal, right? Because I am looking for a test which is of that type, and this should also be satisfied. So certainly my search under C less than 0 fails. Is that okay? Still, I cannot say whether it is UMP alpha or not. It may still be a UMP alpha. Because right now I am trying to look at that UMP alpha test. Only when I have found that test, I'll compare the power of this with that test and see. Suddenly power here is 0, right? Probability of type 2 error is 1. Probability of type, right? So that is, no, probability of type 2 error would be 0, right? In this case, because power is also 1. Okay, so C is less than 0 doesn't. Case 2, I try to look at C is equal to 0. Whether with C is equal to 0, I can get a test of this type, which is UMP alpha test. Note that right now, my job is only to find a UMP alpha test. And what is a UMP alpha test? Any test which is of that type is UMP alpha if there are C and gamma. So I'm just trying to look at that part now. Okay, now C is equal to 0. C is equal to 0, then what is my delta x? I just need to consider the sign. It is 0. X1 is greater than theta naught, less than theta 1. Is that okay? And C is equal to 0, then this is a positive quantity, right? Positive if X1 is bigger than theta 1. So what does that mean? My phi x becomes gamma if X1 lies between theta naught to theta 1 and 1 if X1 is bigger than theta 1. Is that okay? But still, I cannot say that you UMP alpha test unless I show that there are gamma and C anyway is 0, unless I show that there is a gamma which would satisfy E theta naught phi x equal to alpha. Is that okay? So now I try to look at whether E theta naught phi x is equal to alpha. What does that mean? That means gamma times probability that I need not bother about X1 greater than theta naught because X1 is always bigger than theta naught. Is that okay? I need not consider X1 greater than theta naught because in this case, probability theta naught, X1 is less than theta 1 plus gamma times probability under H naught that X1 is bigger than theta 1. Just make sure that I'm not making any mistake. What happened? Oh, yeah. Is that okay? Now, note that this all is under H naught when theta naught is true. Under theta naught, the range of X1 is bigger than theta 0, right? Under H naught, X1 is bigger than theta 0. So x1 is over here and theta 1 is over here. What is the distribution of x1 in exponential case? Under h naught, that means theta is equal to theta naught. You know that minimum again has exponential, right? So n times x1 minus theta naught. Under h naught means theta is equal to theta naught by sigma naught is exponential 1, right? So this would be same as, let me write it down over here so that, or let me use this part. Yeah, let me use this part for the time being. So this is gamma times, I can make it a standard exponential by dividing n times x1 minus theta. So this would be same as gamma times 1 minus e to power minus, because I write down this as x1 greater than e to power minus n by sigma naught, theta 1 minus theta naught. Is that okay? Plus probability that x1 is bigger than theta 1, which under h naught would be nothing but e to power minus n by sigma naught, theta 1 minus theta naught. Should be same as alpha. Is that okay? Actually, it would be gamma. You can put gamma times minus 1 times. Right? So you can get what your gamma is. Gamma should be same. And so I get 1 gamma. Right? But the only thing is my gamma has to be between 0 to 1. We have to make sure that this quantity is between 0 to 1. That would put a condition on alpha. Right? Because my gamma cannot be more than 1. So gamma turns out to be how much? Alpha minus e to power minus n by sigma naught, theta 1 minus theta naught, divided by 1 minus n by sigma naught. Just make sure that I am not making any calculation mistake, because then conclusions may vary. So first of all, my gamma is this, but my gamma has certain restrictions. It should be between 0 and 1. If it is greater than or equal to 0, that shows your alpha should be less than e to power 1 minus e power minus n by sigma naught theta. If alpha is bigger than that, this test again is not going to work. And this should also be less than or equal to 1. Less than or equal to 1 is always true. This is anyway always less than or equal to 1 is not an issue. Only greater than or equal to 0 is equal. So this is a UMP alpha test only when alpha is less than or equal to, sorry, this would be greater than or equal to 0. So alpha is greater than or equal to e to power minus n by. So UMP alpha test or MP alpha test when this should be, gamma should be greater than or equal to 0. That means alpha is greater than or equal to e to power minus n by sigma naught, theta 1 minus theta naught. I hope I am not making any mistake. This was okay, right? X1 bigger than theta naught, less than theta 1 is okay. C, you're talking about 0, yeah, and then it is positive. Yeah, so that is okay. No, what are you saying? Yeah, greater than, because alpha, here you're taking alpha to be strictly between 0 to 1, right? So alpha should be greater than. No, gamma can be 0 and 1. Gamma is not a problem. So you need alpha is equal to this. This is only, it's okay. Right now, so any other thing is yeah. So this is the thing. Now the question is, yeah. So now let us look at the case 3. When what happens? C is equal to 0, and then C greater than 0 and less than, so that this is not 0, right? So what would be that? C less than n theta 1 minus theta naught by sigma naught, right? So another case is C greater than 0, less than e to power n by sigma naught theta 1 minus theta naught, right? Because that would be the case where this is positive and this is negative, right? So phi star x, what is phi x over here? C is positive, that means this is negative. So 0. So first you can write down C delta x of that. C is greater than 0, so it is negative quantity, right? Negative. If x1 is greater than theta naught, x1 greater than theta naught, I need not write because that is always true. So x1 less than theta 1. And this would be positive if x1 is bigger than theta 1. So what does that mean? This means phi x would be negative, means phi x is 0. 0 if x1 is less than theta 1, and 1 if x1 is greater than theta 1. But I want e theta naught of phi x to be alpha. So I look at e theta naught of phi x, which is probability that x1 is greater than theta 1, right? Which would be nothing but e to power minus n by sigma naught theta 1 minus theta. Sorry. So this can be UMP alpha test only when alpha is exactly same as e to power minus n by sigma naught theta 1 minus theta naught. Otherwise not, right? Because I have to satisfy that. I would not say this would be my statement should be a correct statement would be with alpha is equal to e to power minus n by sigma naught theta 1 minus theta naught. This is a UMP alpha test. Which is actually if you look at is kind of this test, right? Because alpha is equal to e to power minus n by sigma naught theta 1 minus theta naught, gamma is 0, which you get as exactly this. So these boundary things you can get from both the sides, right? Which makes sense, right? Okay, so are you writing somewhere case? So I've got UMP alpha test for basically this only you should write it down, right? For alpha greater than or equal to n. Now what is the case left? Because I have to exhaust all C and gamma. because UMP alpha test is among those. So I am just looking for suitable C and suitable gamma, right? Because UMP alpha test is this thing. I have to only search C and gamma such that they satisfy this. So I'm partially successful in case 2 with C is equal to 0, which gives me this test. And why I'm partially successful? Because it is a UMP alpha test only for selected values of alpha, which is basically alpha greater than or equal to e power minus n sigma naught by. So the question arises, what is a UMP alpha test for alpha less than this? Because existence part of the first part of Neyman-Pearson lemma says there has to be a UMP alpha test. So I cannot leave it over here and say that, look, the UMP alpha test is this. UMP alpha test is this, but only when alpha is greater than or equal to this quantity. And that is why I'm trying to exhaust all the C's first. If I've exhausted all the C's, they will exhaust all the kind of situations, and you'll have a UMP alpha test for all kind of situations. Okay. Now what is the scenario left? C is equal to e to power n by sigma naught theta 1 minus theta naught. Okay, so let me write it down over here. Case 3. So case 3 doesn't help me anything because case 3 is contained in case 2 itself. Case 1 doesn't help me because case 1 is also contained in case 1 anyway. Alpha is between 0 to 1 doesn't help me. Now I look at case 3. Case 3 we have done, right? Case 4. Case 4 is when C is exactly equal to e to power n by sigma naught theta 1 minus theta naught. All right. What is my, anyway, here C is positive, so it is negative, right? Delta x is negative if x1 is less than theta 1, because greater than theta naught is always true. And in this case, it is 0. In this case, it is 0. So that means this is gamma, sorry, 0 if x1 is bigger than theta 1. So what is my phi x? Negative means my phi x has to be 0. 0 if x1 is less than theta 1. And gamma if x1 is greater than theta 1, right? Let me just use this space. I don't want to, so actually let me write it down, that test over here. Phi x is equal to gamma if x1 is less than theta 1 and 1 x1 greater than theta 1. This is for the case 2. Now case 4 I'm doing. Now I guess I can remove this. I have to find, this would be UMP alpha test provided gamma satisfies e to power theta 0 phi x equal to alpha. So e theta 0 which is same as probability that under H naught. So that means gamma times probability under theta naught x1 less than theta 1 is alpha. That means gamma times probability x1 greater than theta 1 is, I standardized it with respect to exponential. It becomes e to power minus n theta 1 minus theta naught by sigma naught is equal to alpha. That means gamma is nothing but alpha times e to power n theta 1 minus theta naught by sigma naught. But I required existence of C greater than or equal to 0. and gamma between 0 and 1. So this would satisfy my existence part only when gamma is between 0 and 1. Suddenly alpha is greater than 0, so this is suddenly greater than 0 because exponential something is greater than 0. So this would be UMP alpha test only when this is less than or equal to 1. That means alpha less than or equal to e to power minus n theta 1 minus theta naught by sigma naught. Is that okay? Note that that covers the case where alpha is greater than or equal to this thing, and this covers the case where alpha is less than or equal to this thing. But still it is, I'll try to go for some more. It's still one case is left, right? Case 5, which would be a straightforward case. Of course, that would be covered over a boundary over here. So let me write down case 5 when C is bigger than e to power n by sigma naught theta 1 minus theta naught. This is negative, this also become negatives. So delta x is always less than 0 for every x. And if delta x is less than 0, what is my phi x? Is 0. And what is for this test e theta 0 phi x? Is equal to 0. I wanted it to be alpha. So this case also fails. So you just see, I needed a little bit patience, right? Otherwise, the exercise was straightforward. The whole problem was enumerate each and every case. Patience. Now my answer is over here. So, of course, theta 1 less than theta naught. I would suggest that you try to do theta 1 less than theta naught of your own. Right? Exactly, you have to repeat the same thing. Okay, so my answer becomes for alpha greater than or equal to e to power minus n by sigma naught theta 1 minus theta naught less than or equal to alpha less than or equal to 1. MP alpha test is phi x is equal to gamma, and gamma turns out to be this quantity alpha minus e to power minus n by sigma naught theta minus theta naught upon 1 minus e to power minus n by sigma naught theta minus theta naught. If x1 is less than theta 1, and 1 if x1 greater than theta 1. Is that okay? That is for this situation. Let me write down for the other case. For alpha strictly less than alpha greater than 0 less than or equal to e to power minus n by sigma naught theta 1 minus theta naught. What is my phi test? Phi x is MP alpha test is that is 0 0 if x1 less than theta 1 and gamma turns out to be how much? Alpha e to power minus if x1 greater than theta. Is that okay? So I found you only 4 most powerful tests only for theta is equal to theta naught against theta is equal to theta 1. It is only the first part which helps me in finding one UMP alpha test. Now the question arises, are these unique? Right? There is a question arises. Now, if I have to answer that, again, I know that then is equal to 0 part, I have to separate it out. Because I know that every UMP alpha test would be of phi x equal to 1 if delta x is greater than c times delta 0x, and 0 if that is less than that quantity. Where it is exactly, I can play around. Right? That is the reason where I can play around. So if I have to find more, I have to now go back to doing the same exercise and see whether I can get a test of same power. What is the power in this case? So that means I'll need to calculate the power of each of these tests. Right? You see, one test I can already get through that MLR property, right? Because in this case, minimum has a MLR property, right? So that result for MLR I can always get. Second thing is, one disadvantage with each of these tests is they all depend on choice of theta 1. So suddenly none of these tests can be uniformly most powerful for testing theta is equal to theta naught against theta greater than theta naught. So that means now the question arises is, can I get some test which has the same power as this, but they do not depend on theta 1? Advantage of that test would be that would be UMP alpha for this situation. And that would also be UMP alpha situation for the situation where theta is equal to theta naught against theta greater than theta 1. Of course, one such test you can get from that MLR thing, right? It immediately gives you a test. What is that test? So I need not repeat that exercise. I try to see what is the MLR test because that is a much more. So let us consider f theta 1x by f theta 0x. So x1 is always bigger than theta 1 naught, so theta naught, theta 1 and 0. So if x infinity, right? If x1 is less than theta 1, of course greater than theta naught, I'll always assume. Then what happens? F theta 1 is 0. In this case, the density of theta 1 would be 0, so it would be 0 by some positive quantity. So it would be 0. And if x1 is bigger than theta 1, it is not going to depend on x1 because your density depends on 1 by sigma naught to power n, e to power minus summation xi by sigma naught, and e to power n theta 1 by sigma naught. There is no x1 comes over here. X1 only comes in the range, right? Which is taken here. So it will be some positive quantity. Is that okay? And this is increasing because it from 0 it goes to 1. So it is increasing. So uniformly most powerful alpha test for H naught, I just use Just to save my time, you could have done that exactly and consider only when delta x is less than 0 and get is equal to 0 and try to look into it. I just want to make my life simpler because I already have an advanced test which gives me a UMP alpha test in this situation. Because here you are rejecting for a larger values of theta. So what should be my test? Anyone? How should my test should look like? 1, if in whatever you have MLR is greater than C, gamma if x equal to C, and 0 if x less than C. So 1 gamma if x1 is equal to C, and 0 if x1 less than C. Now note that here x1 is equal to C makes no sense because it is a continuous distribution. So probability x1 is equal to C is will be 0 in this case. So this is not going to make sense. So that means you have to only determine constant C. And how does you determine C? E theta naught is that okay? What does that give? That means C times probability under theta naught, x1 is greater than C is alpha. Right? So of course, what does that mean? E to power C times, oh, there is no C, right? Just this one. That means e to power minus n by sigma naught, C minus theta naught should be same as alpha. Is that okay? That means it is okay, e to power minus n by sigma naught, C minus theta naught is same as alpha. Yeah. That means minus n by sigma naught, C minus theta naught is same as log of alpha. This comes over here. That means C minus theta naught, C same as theta naught minus sigma naught by n log of alpha. Is that okay? Now note that this test certainly does not depend on theta 1. Now you can do a back substitution. What can you infer from this? Will this test also be UMB in the earlier situation? Yes, because it maximizes power at every theta greater than theta naught. And its label is alpha. So supremum of phi is always less than or equal to alpha for all theta less than or equal to theta naught. So at theta naught also it would be less than or equal to alpha. Right? So this would clearly be most powerful in that situation also. And you can calculate the power. Power will turn out to be the same in both the cases, right? At point theta 1, bigger than theta naught, power will turn out to be the same. I'm just avoiding all that exercise because once I have done a theorem, I know their power is going to be the same. Why should I derive it? If I didn't have a theorem for MLR and I had to do it, then I would search for a test which is independent of theta naught, right? And then conclude. But I have already proved that result. You have any doubt? I think it clarifies to. If still you might have some doubt. So what I would say is theta less than theta naught. Again, repeat that uniform theta plus 1. Advantage of uniform theta plus 1 is it doesn't have MLR because it would be in exponent xn. So test only theta is equal to theta 0 against theta is equal to theta 1. Possibly UMP alpha test may depend on theta 1. But then try to find out a test which does not depend on theta. That will give you further insight into Neyman-Pearson lemma. Slightly complicated, but it will give you more insight into Neyman-Pearson. If you want to get 100% insight into Neyman-Pearson lemma, then I would encourage you to do uniform theta plus 1 of your own with the patience I had in doing this. You'll need more patience because you will not have a MLR kind of a thing. So if you have to extend that test for theta less than or equal to theta naught against theta greater than theta naught, you'll have to do much more struggle, right, than what I had to do today. Because I already had a result for theta less than or equal to theta naught against theta greater than theta naught when I have a MLR property. Uniform theta theta plus 1 will not have MLR property because it will have x1 and xn two statistics. Normally, when we have talked about MLR, it is in one statistic, right? Because minimal sufficient statistic in uniform theta theta plus 1 is x1 and xn. Okay. So try to do that, and next tomorrow I'll take up other things. Unless you have some doubts in Neyman Pearson lemma, I'll try to do, because there are 6A assignment also I have posted, which was on this Kramer-Rao bound, right? I had forgotten to give a homework on Rao-Kramer bound. So we'll take up that assignment and other Neyman Pearson lemma problems if you have any. So tomorrow at 10, let me find out the time for the classroom. If this room is available, we'll have it over here, otherwise somewhere else. The 10 is final, right? Tomorrow?